Today, we want to treat the topic friction. And in the process, we are going to expose some of the secrets to answering both theoretical questions and calculations in physics and chemistry as well, which in most cases, students find it extremely difficult to arrive at the right answer because they lack the backgrounds. They may know the formula, but they may not even apply it properly. Now, by definition, friction is a force that opposes motion when there is relative motion between two bodies in contact. So that's just the definition of friction, which you can get from the text, various texts. They always put a definition in various terms, but they just mean the same thing. Now, from the definition that friction is a force that opposes relative motion of two bodies in contact, that suggests that friction is an opposition. It opposes motion. Because you might be asked, which of the following statements is correct about friction? Friction opposes motion. Now, in this case again, we have formula written uppermost that F equal to mu R. The students have been using this without knowing the application and what you can get out of this. Very useful. Now, this F, you have to know that the F here is the frictional force. So you will not have a misconception of idea. It's not just any other force. It's the frictional force. Then this one now is the coefficient of friction. This is the coefficient of friction, which is a measure of the roughness of the surface. Then this R is the normal reaction. The normal reaction is a vertical force that opposes the motion. That opposes the weight of the body. The normal reaction is equal and opposite to the weight. The weight is W, and that is the normal reaction. The weight itself is mass times the gravity. So that's just for the normal reaction. We will explain all these things maybe when we'll be handling calculations. Now, we want to use this formula. We want to apply this simple formula in friction that F equal to mu R to answer JAMB questions on the topic friction. Now we can see number one here. Which of the following combinations is true of sliding friction? That's JAMB 2003, number 3. Then, when this kind of question comes up, you'll be able to capture what the formula is all about. The terms here, these parameters, the quantities, both mu, which is the coefficient of friction, and the normal reaction. They will now tell you the relationship that the frictional force depends on these two quantities. The coefficient of friction and the normal reaction. Now, the first one now says, frictional force is independent of the area of the surfaces in contact. You see, following the formula, there is no area here in the formula that F equal to mu. There's no area there. Meaning that frictional force does not depend on the area of the two surfaces in contact. It's independent of that. Then I says, and we are looking for the correct combination. So now, frictional force is independent of the area is right. So we take I first, that frictional force does not depend on the area because the area is not there in the formula, so it's independent of the area. Then 2 says, frictional force depends on the nature of the two surfaces in contact. That's good. That is this coefficient of friction is a measure of the roughness of the surface. So this roughness is a measure, that's the nature of the surface. So, and it says now that frictional force depends on the nature. Yes, that is there in the formula. So 2 is also true. That frictional force depends on the nature of the two surfaces in contact. Then 3 says frictional force depends on the speed of sliding. Unfortunately, there is no V in the formula. We don't have a speed We don't have velocity. So frictional force does not depend on the speed of sliding or velocity or relative velocity of the two bodies in contact. It's independent of that. So we can't accept 3. Now, IV says frictional force is directly proportional to the normal reaction. That's R in the formula. So frictional force depends on the normal reaction. Frictional force is directly proportional to the normal reaction. So we equally take 4 as a true statement. So the correct answer now is 1, 2, 4. That's option A is the correct answer.